For today's lesson, it does to say that the title is Notes on Similar Polygons, but more importantly, we're talking about their perimeters and areas. We already know by definition that similar means that all the angles in the shape are congruent between the two shapes, and that all of the corresponding sides are proportional. It means in general that our two figures will be the same shape but not the same size. So when we take a look at the two triangles that are first given to us, we can see that they do look like they're the same shape, but they're going to ask us to prove that. So for example number 1, it tells us that we're supposed to find the following ratios. So I'm going to take side AB and put it over side DE, which gives me 8 over 12. Which does reduce to 2 over 3. And then I'm going to go through and do the next one, and I'm going to put side BC over side EF, which is 6 over 9, which reduces to 2 over 3. And then the last set of sides, AC over DF, 10 over 15, which we have right here, which does reduce to 2 over 3. So by the fact that all of these sides are proportional, it's a way to prove that our two triangles really are similar to each other. We're going to take that idea one step further and compare the perimeters of the two triangles. So we've talked numerous times this year about their perimeters, and for the first one, when I do the perimeter, I'm adding up all the sides, which gives me 24. In the other one, I'm also adding up all the sides. So this is going to be 12 plus 9 plus 15, which gives me 36. So if I take the two perimeters and I write them as a ratio, 24 over 36, it reduces to 2 over 3. You're supposed to notice that there is a relationship here, because whatever the ratio of the sides is, remember we got 2/3, 2/3, 2/3, the ratio of the perimeters will be exactly the same. So I'm going to fill that idea in right here. If two polygons are similar, the ratio of their perimeters is the same as or equal to, if you want to put that in there, the ratio of the corresponding sides. We're going to take this idea one step further again. They want us to compare the areas of the two triangles. So when I compare the areas, one of the things that I have to remember is, how do I do the formula for the area of a triangle? And we know that we use the rule or formula 1/2 base times height. The base in the first triangle is this side, BC, and the height is this side, AB, and I know they're the base and the height because they hit at a right angle. So this is going to be 1/2 of 8 times 6, which is going to give me 24. When I do the area of the second triangle, I'm going to use that same idea. Area equals 1/2 base times height. My base and height are the two sides of the triangle here again, because they do meet at a right angle. And I end up getting 54. So when I take the ratio of the areas and I put 24 over 54, most of you are going to expect that to reduce back to 2/3, but it doesn't. It reduces to 4/9. So there's a little bit of change when we compare the areas, the ratio of the areas of the two figures. One thing that I do want you to notice though is, if you compare these two, the 2/3 and the 4/9, they would be equal if I did this. And some of you already may see this. If I took this and I squared it. So if I square a fraction, I square the top, 2 squared is 4, and I square the bottom, 3 squared is 9. So if I want to figure out what the ratio of the areas is, what I need to do is do the square of whatever the ratio of the sides is. So this is actually extremely easy, provided that you remember the rule. So let's take a look at example number 2. In example number 2, they want us to find the ratio of the corresponding sides. Now, when I look at this, I can see the ratio of the sides, for the two sides I know, 12 to 8. So this is 12 over 8, which reduces, when I reduce it, I'm going to divide by 4 on top, divide by 4 on bottom, is going to be 3 over 2. When I get to part B, it says the ratio of the perimeters. It doesn't mean I have to go back and find the perimeter of all of them. Because I remember this rule from up here, if I know what the ratio of the sides is, which I just figured out, the ratio of the perimeters is exactly the same. And then for part C, find the ratio of the areas. What does that rule tell us that we do? If we want to know the ratio of the areas, we take the ratio of the sides and square it. So this is going to give me 9 over 4. And it works for any shape at all. In example 3, they're going through and they're doing that with a quadrilateral instead of doing that with a triangle. And the same thing holds true. So just take a quick look at this one. You don't have to write this down if you don't want to. I have two quadrilaterals, W, X, Y, and Z, W prime, X prime, Y prime, and Z prime. And it says that WX and W prime, X prime are in a ratio of 3 to 12. One of them's 3 and one of them's 12. Ratio of the sides, 3 to 12, which reduces to 1/4. Ratio of the perimeters, equal to the ratio of the sides, so 1 over 4. Ratio of the areas, this is where we have to square it, is equal to 1/4 squared. When you square a fraction, you square the top and get 1. You square the bottom and get 16. Some of you are going to tell me that 1 times 1, or 1 squared, gives you 2, but it doesn't. 1 times 1 is 1. So please flip your paper over. On the back, we have a couple of examples here. And I'm going to actually write down some rules for you before we go too far. So rules that you can use based on those ideas we just had. So here's my rules. I know that if I know the ratio of the sides, it'll be equal to the ratio of the perimeters. If I'm comparing the ratio of the sides, though, and I'm comparing it to the areas, I can't put the equal in there unless I square it. Ratio of the perimeters, because it's equal to the ratio of the sides, means I have to square the ratio of the perimeters to get the ratio of the areas. So those are the 3 formulas. I will give those formulas to you on your test, so you really just need to know how to fill in, decide on the formula and fill in which it is that you're going to use. So for question number 4, we have a quadrilateral. 4 sides. It says that we also have a similar quadrilateral, and our similar quadrilateral has a perimeter that's 104. It wants to know the length of the longest side of this quadrilateral. So as I look at this quadrilateral, if these two are similar and the longest side over here is 8, then this has to be the longest side in this one. It has to sit in the same place. I'm comparing sides and perimeters. So using the formula that I know, I say a side here matches up to a side here. And perimeter here, I don't know that perimeter. Or do I? Is there a way to figure it out? Of course there is. We can go through and add up all these sides, which will give me 26. So when I add up all the sides, I get 26, which I can put in here over the perimeter of 104. So side over side equals perimeter over perimeter. So I'm going to cross multiply and solve. So 26x equals 832, divide by 26, gives me a final answer of 32. So the perimeter of, the largest side of the second quadrilateral is 32. Question number 5, perimeter of a hexagon. So they're talking about a hexagon here. You're supposed to remember that that has 6 sides, so there it is. Not fancy, you know my artwork is less than perfect. It's telling me the perimeter here is 8, and its area is 80. It says we have a similar hexagon with an area of 45. So I'm going to draw a similar hexagon. And my area here is 45. And it's asking me what its perimeter is. So just like we've kind of done throughout this unit, I'm going to put an X on what I'm looking for. And if I take a look at the two things I'm comparing perimeter and area. So this is the formula up here that I want to use. So I'm going to say perimeter over perimeter squared equals area over area. Plug in the perimeters you know, plug in the areas you know, and do your math. So over on the left, we have to do 8 squared, because this whole fraction is squared, which is 64, over x squared, which is just x squared. And then I'm going to cross multiply. So 80x squared equals 2,880. Solve for x by dividing by 80 is my first step, which gives me 36. And then to use Connor's rule, how do we get the x alone? We have to put that little thing over it, which means that we're square rooting, which means I'm going to get x equals plus or minus 6. Remember, you get 2 answers, but we're only keeping the positive one. Question number 6. Two triangles are similar. I'm going to draw my two similar triangles. The smaller one has side lengths of 4, 6, and 8. The perimeter of the larger one is 27. Find the length of the shorter side of the longest triangle, the shortest side of the larger triangle. The shortest side in the small triangle is here, which means the shortest side in the big triangle has to be there as well. If I look at what I'm comparing perimeters and side lengths. So I'm going to look at the formula that compares perimeters and sides. Plug in what I know. 4 over x equals, I don't have the perimeter of this triangle over here, but remember we can add up all the sides to get that. So 18 over 27. Cross multiply, so 18x equals 108 divided by 18 gives me an answer of 6. And I'm going to skip question 4, no reason other than just to make sure that we're not talking too long.